kind of where the state's been and where it's going to be going. So just the agenda for this is we'll talk about the California production imports and national trends, getting into some of the geopolitics and pricing, which will become evident, with the energy use and a little bit about repurposing, which is one of the businesses I'm involved in these days, and we'll have time for some discussion. But the first point is transportation fuels. This is the main part of the barrel of oil. The biggest part that's being used is gasoline. And you can see from this chart that from 2000 till COVID, it was pretty flat, maybe growing a little bit. Big drop in COVID, never recovered completely back from there. But this data only goes to 2022, so EIA doesn't have the last few years. So the point of this is there's a very large consumption of petroleum products for transportation fuels, and that probably will continue to persist. Where is oil in California? So maybe people don't know this. California was the place of the first commercial oil in the United States. People talk about Drake's Well in Pennsylvania, but actually up in the Ventura Basin was the first place where the first commercial oil was developed. And before that, there was a very long history of, especially the indigenous peoples, using oil slips for sealing their boats. So there's a lot of oil coming out of the ground all over California. But there's 4 principal basins in California that produce oil. Sacramento is dominantly natural gas. The San Joaquin Basin is the biggest one, of about 20 billion barrels of oil equivalent, and that's where most of the production today is coming from. Ventura Basin, a little smaller. Los Angeles Basin is a small basin, but interestingly, if you look at the amount of oil that's in that basin per cubic volume of rock, it's the richest oil basin in the world. It's all houses on it now, and so it's in a state of decline, but that's kind of the history of where all the oil came from. If we look at the history of exploration and development in California, it's an interesting story. So all of the biggest fields in California were discovered between 1890 and 1920. And you're talking about the giant fields in the San Joaquin Valley, the giant fields in the LA Basin. The natural gas was really discovered a little bit later. But the last big discovery in California was the Yolumne field in 1970. And that was a 50 million barrel field. So by the standards of things like Wilmington oil field in the billions of barrels, Elk Hills in the billions of barrels, it was a very small discovery. So since then, what we've been looking at more are production methodologies to increase production, and specifically thermal recovery, which is a steam work that's being done in the largest remaining oil deposit, which is in the west side of the San Joaquin Valley. But really, after that, there's one new discovery in Monterey County by Trio Petroleum, but it's a few million barrels. So you can see that since 1970, there really hasn't been anything substantial, and even before that, really since 1940, there hasn't been anything substantial discovered in California. Just interestingly, the geophysical techniques that are so common around the country today started in 1932, and the very first oil field in California discovered with a seismic method was the giant offshore Wilmington field in the Long Beach Harbor. So we look at production then, and we see 2 curves here. The top curve is national production, and the bottom curve is California production. And you can see California's been in steady decline for a long time, while the rest of the country was increasing. There's the COVID dip again, and then a very, very steep increase in production on the national scale. Let me point out that all of the oil fields in the United States, with the exception of those in West Texas and the Permian Basin, are in decline. So that uptick on the very end of that on the national scale is 100% from the Permian Basin, offsetting all the rest of the decline in the state. But you look at the data for the Permian Basin, and you listen to what the people have to say who work those areas. The chart on the top is looking at growth of production in the Permian Basin. And you can see the growth is declining over a period of time. And when you listen to people like Vicki Hollub, who's the CEO of Oxy, who has a very, very big stake in the Permian Basin. So they're looking at peak oil out there sometime, around 2030. Most of the shale executives, and Howard Ham, who's the head of Continental Resources, was on record as saying that basically all of the big discoveries have been found in the Permian Basin, and so they're really going into harvest mode. But having said that, one of the things that's happened over the history of oil production in the United States is that clever people have found new ways to look for resources and clever ways to improve their production. But the bottom chart is also telling. And the blue parts of those pie charts are the water production, and the black parts are the oil production. You can see that most of these fields are dominated by water production, in particular the Permian Basin. So this has to do with the geology and the producing practices, but one of the big challenges is what do you do with all of that water that comes up with the oil, and so that becomes kind of an operational problem. Getting to California. So I'm sure everybody's seen this chart many times, but it shows, again, the decline, starting around a steep decline or a steeper decline around 2014 in California production, the Alaska production, which was a substantial component back in the 60s, is declining. And now the foreign oil coming into the state is increasing. Again, you see the little COVID dip there, but it's recovering back again to 2023. So the numbers on this is about less than a quarter of the consumption every day in California comes from California production, about 16% from Alaska, and over 60% from foreign sources. So let's take a look at what those foreign sources are. And you can see there's quite a number of countries that are providing oil to California. But there's some notable points in here to really look at, and one is Alaska has been kind of steady, but the purple one above Alaska is Saudi Arabia. So you see a tremendous decline in contribution from Saudi Arabia, replaced a lot by Iraq and a little bit by Ecuador, and this is in this nebulous other category at the top. But this is the mix of oil coming in historically from foreign sources. So people ask a lot of questions about why is California oil production declining. So there's a few signals in there that I think are important. And one, I already mentioned that the last big discovery in California was in 1970. So new oil fields have higher production rates than old oil fields. It's a function of the pressure decline in the reservoir. The other thing is price. So on this chart, the green line at the top is oil price, and you can see that around 2016, with the price crash, the number of permits that were issued also went down commensurately with it. But the question is also whether the permit flow is affecting the production. You can see there's actually probably a signal from all three of those in here. You look at this chart, and the light green bars are the total number of permits. The red bars are the abandonment permits, the blue are the new drill permits, and the purple are the rework permits. So certainly between 2010 and 2015, you're seeing quite a number of new drill permits being issued. But since then, has been declining. What has been increasing, though, is the red bars, which is the abandonment permits in the state. This is a function of a number of things about policy, about the age of the oil fields, et cetera. But this is really the trend and what you're seeing with the permitting flow for oil and gas wells in California. Getting back to the foreign components, this pie chart here is just showing just the foreign components. It doesn't include Alaska. And what you can see from here is that the top three countries that contribute to the imports into California: Iraq, Saudi Arabia, and Ecuador. And that's well over half of the imports into the state. If you take a look at Iraq and Saudi Arabia, which are going to be important in the next slide I show, they're over a third of the oil imports into California every day. And it's important because of the geopolitical supply risks. So we take a look at this map, and you can see the big circles over there in the Middle East, going out through the Straits of Hormuz. But even more importantly, or as importantly, is that all that oil goes through the Panama Canal before it gets to California. So you've got a couple of pinch points there geopolitically. So if there's a shooting war that starts out in the Middle East, the Straits of Hormuz could very likely close or be restricted. And who knows what's going to happen with the Panama Canal. There's lots of discussions going on about that now. So either of those points become restricted or closed. So California loses about a third of the oil production from the Middle East. So those two places, Hormuz and Panama Canal, are really key transportation routes for imports into the state. And then we look at California itself. There are no crude oil pipelines that cross the state lines into California. So all of the oil comes in through ships and a little bit by train. There is a refined product line that goes out through Arizona to Texas, but there's no pipelines coming into the state to supply the refineries with crude oil. It has to come in through boats. So pricing is always interesting. We talk about it a lot, what drives prices. Well, this chart shows historical events have a big impact on pricing. As you can see, some of the big ones in 1978, or 1975, sorry, with the oil embargo. I was in high school. My mom gave me the keys to the car. Said, "You go sit in the line for 3 hours to get gas." But you can see that the price goes up and down as a function of world events. And here we are today, the oil price is in free fall. And interestingly, and this is actually for the next slide, is actually explains this. The price of oil doesn't necessarily go up and down because things happen, although it does. But it also goes up and down because people think something might happen. So it's really a function of going to the New York Mercantile Exchange, and people are making bids for futures on oil. And they pick up the Wall Street Journal and they go, well, there's tariffs. There's going to be there's an increase by OPEC plus of raising their limits. And even though that happened the other day, why did the price of oil crash? The next day they haven't put any of that oil into boats yet. But still, the futures market responds to what things might happen as well as the things that do happen. So the job of these oil futures buyers is really, again, trying to see around corners of what's going to happen. Is there going to be a supply pinch or a supply glut? And they're bidding on futures contracts for crude oil as a function of what they believe is going to happen. Let's take a quick look then back to California, and I want to talk about two different things. One is the kinds of wells that we have in California, and the other one is the kinds of operators that we have in California. Let's first talk about the wells. So the pie chart in the top, really there's three major pieces to it, and those are active, plugged, and idle wells. So you can see that the active wells are about 35%. My old eyes don't work anymore. The plugged are about 42%. There's a big chunk in there which are idle wells, and I'll talk a little bit more about idle wells. But I also want to talk about the operators. So there's a lot. The way this chart is set up, on the left-hand column, there's numbers 0 to 5, and then at the bottom, greater than 10,000. So these are a characterization of operators who have that many wells, right? So there's 2,000. There's 72 operators that have 0 wells in California. There are over 1,000 operators that have between 1 and 5 wells in California. And then when you take a look at the companies that have more than 10,000 wells, there are 5. Right? So most of the wells are in the hands of very few companies, and that's actually good news because most of them are fiscally responsible and have reserves for taking care of the abandonment of these wells over the long term. So, but most of the operators in the state have very, very few wells, and so as a regulator, we talked about where are the risks for wells going from idle to orphan, in other words, becoming a state liability, and we always were concerned more with the companies that Bill's Deli and an oil company. I've got 3 wells, and that might be more of a risk to go to the idle state, or the orphan state, where the state of California would have liability for abandoning that. But anyway, that's kind of a characterization of the wells and the operators. But let me talk a bit more about idle wells. So there's about 39,000 idle wells in California today. There's hundreds of thousands of them across the United States. And when you have incidents such as a rapid drop in oil price, a lot of wells that were economic yesterday are not economic today. And so those become idle. In California, there's actually a definition for idle, and they have to be non-productive for a certain period of time. We're the only state that has such a designation. Most of the other states do not. But in any case, these are wells that have been non-productive for little as 8 months and as long as 20 years. So what do you do about these things? Well, one thing is you can cause them to be abandoned. There's a number of policies, legislation, and regulations that have gone into place to create incentives for those to be abandoned. But there's a new school of thought going out there, and I want to talk about. There's a few companies that are talking about is there a potential for repurposing these end-of-life wells to do a few important things. One is to seal off the hydrocarbon zone to eliminate any actual or potential fugitive methane. And two, is there something you can do lucrative with this, such as convert it into an energy storage system? We just heard about the need from CAISO to have long duration energy storage, right? It's an important part of the go forward strategy for the state. So there's four ideas, and there's probably more. These are four that I know of that are out there in the marketplace today, talking about taking these end of economic life oil wells and converting them into long duration clean energy storage. One is about using compressed air. It's a pressure energy strategy. There's another one that says using high temperature steam and loading up reservoirs with that, and then reproducing it to generate electricity. There's one that's a gravity-driven potential energy technology, which is basically dropping a weight down into a well and spinning a drum. And then a company that I'm involved with, we're looking at thermal energy storage, loading up the well with phase change materials, heating it up, and then harvesting that to generate electricity later in the day or at night after the sun has gone down. So just an idea that some ideas that people are talking about. We've got this tremendous infrastructure, these assets. Is there something we can do with them besides just spend money on them? Can we convert them to something which is actually going to be supportive of the energy storage requirements that we're going to need? So looking at kind of supplies and consumption. So real quickly here, California consumes about 1.7 million barrels of petroleum per day. It's about 280,000. Well, the production is about 280,000 per day. So California produces about 2% of the U.S. oil production, but consumes about 8.5% of it. The refineries in the United States and California, this is an important issue. So both are declining. California is declining faster. So this is as of January 1. Since then, there have been a couple of other refineries that are either planning to shut down or have shut down. California supplies refined products for several states, including Nevada and Arizona. But we take a look then at the reserves and the operations. So EIA estimates there's about 1.5 billion barrels of oil left to produce in California. That's going to be dominantly from the San Joaquin Valley. But the thing that's of concern to me is that the refinery capacity, not counting the ones that are about to shut down, in California is about 1.7 million barrels a day, which is barely adequate to manage the consumption on a daily basis. And at the end, so this is a chart of the California energy production, again from EIA, and crude oil is today still the highest source of energy production in the state. And with that, I was going to say